NEC Section 310.14. D specifies that aluminum wire for direct burial must meet the mechanical properties of hard-drawn alloy 6201 wire, designated as grade 8000. Grade 1030 aluminum is a soft-drawn alloy. It possesses low mechanical strength compared to grade 8000 aluminum. It might be used for some overhead applications, but it does not meet the tensile and yield strength requirements for direct burial and underground applications. Directly burying grade 1030 aluminum cable in soil may create several risks. Firstly, physical damage is a concern. The reduced strength of grade 1030 aluminum makes it more susceptible to damage from soil movement, rocks, or excavation equipment. Secondly, increased resistance becomes an issue. The lower conductivity of grade 1030 aluminum can increase the cable's electrical resistance, leading to higher energy losses and potential overheating. Thirdly, failure under stress may occur. Grade 1030 aluminum is less resistant to bending and pulling forces, which can occur during cable installation or repairs. Failure of the underground feeders due to the use of grade 1030 aluminum can lead to serious consequences, including electrical outages or interruptions, damage to equipment, fire hazards, and safety risks for personnel. It is not recommended to use grade 1030 aluminum cable for direct burial in an all-underground installation because of its lower mechanical strength and increased susceptibility to damage and failure. It is important to comply with NEC requirements and use only grade 8000 aluminum wire for such applications to ensure the safety and reliability of the electrical system. The National Electrical Code, or NEC, serves as the benchmark for safe electrical design, installation, and inspection to protect people and property from electrical hazards. It is important to familiarize yourself with the relevant sections of the NEC when working with electrical systems, especially those involving underground installations. Section 310.14 addresses aluminum conductor requirements, and it is crucial to understand its implications for direct burial applications. Hard-drawn aluminum, also known as alloy 6201, possesses higher tensile strength and yield strength compared to soft-drawn aluminum alloys like grade 1030. Tensile strength refers to the maximum stress that a material can withstand while being stretched or pulled before breaking. Yield strength refers to the amount of stress a material can withstand before it begins to deform permanently. The NEC mandates the use of grade 8000 aluminum for direct burial because it provides the necessary mechanical strength to withstand the stresses and strains associated with underground environments. The soil around buried cables can exert pressure on the cable, and ground movement caused by temperature changes or seismic activity can further stress the cable. The higher tensile strength of grade 8000 aluminum helps it resist these forces, preventing it from breaking or being damaged. The higher yield strength of grade 8000 aluminum ensures that the cable can withstand some degree of deformation without permanently affecting its electrical performance. In contrast, grade 1030 aluminum, which is a soft-drawn alloy, has lower tensile and yield strength. While it may be suitable for certain overhead applications where mechanical stress is less of a concern, it is not adequate for direct burial. Using grade 1030 aluminum for direct burial can lead to several problems. The cable is more susceptible to physical damage from rocks, sharp objects, or even the weight of the soil itself. If the cable is damaged, it could lead to electrical shorts, ground faults, or even fire. Grade 1030 aluminum also has a lower conductivity than grade 8000 aluminum. Conductivity refers to a material's ability to conduct electricity. A material with higher conductivity will allow electricity to flow more easily through it. The lower conductivity of grade 1030 aluminum can lead to increased energy losses in the cable. This means that more energy will be lost as heat as electricity flows through the cable. This can increase the operating cost of the electrical system and can also lead to the cable overheating. The resistance of a conductor is a measure of how difficult it is for electricity to flow through it. Resistance is measured in ohms. The higher the resistance of a conductor, the more energy will be lost as heat as electricity flows through it. Grade 1030 aluminum has a higher resistance than grade 8000 aluminum. This is because grade 1030 aluminum has a lower conductivity. The higher resistance of grade 1030 aluminum can lead to increased energy losses and overheating. In addition, grade 1030 aluminum is more susceptible to damage from bending and pulling forces. These forces can occur during cable installation or during repairs. If the cable is bent or pulled too much, it can be damaged, which can lead to electrical problems. The NEC specifies the types of conductors that can be used for direct burial to ensure that the cables are mechanically strong enough to withstand the stresses of the underground environment. Always use the correct type of conductor for the application to ensure safety and reliability. The NEC also specifies the minimum burial depth for underground cables. This is to protect the cables from physical damage from digging or other activities. Be sure to bury cables at the proper depth to prevent damage. The NEC provides guidance on the proper installation methods for underground cables. Follow these guidelines carefully to ensure that the cables are properly installed and protected. Underground electrical feeders are essential components of many electrical systems, providing power to various loads and equipment. These feeders can be installed using different methods, including direct burial, where the cable is buried directly in the soil. However, selecting the appropriate cable type for direct burial applications is crucial to ensure safety, reliability, and compliance with electrical codes. When designing and installing underground electrical feeders, it is important to consider the mechanical properties of the cable, the soil conditions, and the potential for physical damage. Using the wrong type of cable can lead to a variety of problems, including cable failure, electrical hazards, and costly repairs. One of the most important factors to consider when selecting cable for direct burial is the type of aluminum alloy used in the conductor. Aluminum is a popular choice for electrical conductors due to its lightweight, good conductivity, and relatively low cost. However, not all aluminum alloys are created equal. Different alloys have different mechanical properties, such as tensile strength and yield strength, which determine their ability to withstand stress and strain. As previously mentioned, the NEC requires the use of grade 8000 aluminum wire for direct burial applications. This requirement is based on the fact that grade 8000 aluminum has the necessary mechanical properties to withstand the rigors of the underground environment. Grade 8000 aluminum is a hard-drawn alloy that has been specifically designed for electrical applications. It has a high tensile strength and yield strength, which means that it can withstand significant stress and strain without breaking or deforming. In contrast, grade 1030 aluminum is a soft-drawn alloy that has low mechanical properties. It is more ductile, which means that it can be bent and formed more easily, but it is also more susceptible to damage from physical stress. Using grade 1030 aluminum for direct burial can lead to several problems. The cable is more likely to be damaged by rocks, sharp objects, or even the weight of the soil itself. If the cable is damaged, it can lead to electrical shorts, ground faults, or even fires. In addition to its lower mechanical strength, grade 1030 aluminum also has a lower conductivity than grade 8000 aluminum. This means that it will carry less current for a given size conductor. This can lead to voltage drops, reduced equipment performance, and increased energy losses. In some cases, using grade 1030 aluminum may not meet the requirements of the NEC, which could result in code violations and potential fines. The NEC is a comprehensive set of standards that govern the safe installation and operation of electrical systems. It is important to comply with the NEC to ensure the safety of people and property. When designing and installing underground electrical feeders, it is important to select the correct cable type and size for the application. This includes considering the ampacity of the cable, which is the amount of current that it can safely carry. The ampacity of a cable is determined by its size, insulation type, and the ambient temperature. It is also important to consider the voltage drop in the cable. Voltage drop is the reduction in voltage that occurs as current flows through the cable. Excessive voltage drop can lead to reduced equipment performance and can even damage equipment. To minimize voltage drop, it is important to select a cable that is large enough for the load. In addition to selecting the correct cable type and size, it is also important to install the cable properly. This includes following the manufacturer's instructions and the requirements of the NEC. The cable should be buried at the proper depth to protect it from physical damage. It should also be supported properly to prevent stress on the cable. The terminations of the cable should be made carefully to ensure a good electrical connection. Poor terminations can lead to overheating, voltage drops, and even fires. Regular inspections and maintenance can help to identify potential problems before they become serious. Inspections should include checking the cable for damage, loose connections, and signs of overheating. Maintenance should include tightening connections, replacing damaged cable, and cleaning the area around the cable. By following these recommendations, you can ensure that your underground electrical feeders are safe, reliable, and compliant with electrical codes. Always consult with a qualified electrician or electrical engineer when designing and installing electrical systems. They can help you to select the correct cable type and size for your application, and they can ensure that the system is installed properly. They can also provide guidance on how to maintain the system to ensure its long-term reliability. Underground electrical feeders are essential for providing power to a variety of loads, including buildings, equipment, and outdoor lighting. When designing and installing these feeders, it is important to select the correct cable type and size, install the cable properly, and maintain the system regularly. By following these guidelines, you can ensure that your underground electrical feeders are safe, reliable, and compliant with electrical codes. Grade 8000 aluminum is required for direct burial applications because it has the necessary mechanical properties to withstand the stresses and strains of the underground environment. Using grade 1030 aluminum for direct burial can lead to several problems, including cable damage, electrical hazards, and code violations. The NEC is a comprehensive set of standards that govern the safe installation and operation of electrical systems. Always comply with the NEC to ensure the safety of people and property. Consult with a qualified electrician or electrical engineer when designing and installing electrical systems. They can help you to select the correct cable type and size for your application, and they can ensure that the system is installed properly. Regular inspections and maintenance can help to identify potential problems before they become serious. This will help to ensure the long-term reliability of your underground electrical feeders. Consider the environmental conditions when selecting cable for direct burial. For example, if the soil is acidic or corrosive, you will need to select a cable that is resistant to these conditions. Also, consider the potential for water damage. If the cable is likely to be exposed to water, you will need to select a cable that is waterproof. Proper grounding is essential for the safe operation of electrical systems. Make sure that your underground electrical feeders are properly grounded to prevent electrical shocks and other hazards. Overcurrent protection devices such as circuit breakers and fuses are designed to protect electrical circuits from overloads and short circuits. Make sure that your underground electrical feeders are protected by overcurrent protection devices of the correct size and rating. Surge protection devices are designed to protect electrical equipment from voltage surges such as those caused by lightning strikes. Consider installing surge protection devices on your underground electrical feeders to protect sensitive electronic equipment. Follow these additional safety tips when working with underground electrical feeders. Always energize the circuit before working on any electrical equipment. Use insulated tools and equipment. Wear appropriate personal protective equipment, such as gloves and safety glasses. Be aware of the potential for underground utilities, such as gas lines and water lines. Call 811 before you dig to have these utilities located. The information provided here is intended for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical engineer when designing and installing electrical systems. Grade 8000 aluminum wire, required for direct burial by the NEC, offers superior mechanical strength compared to grade 1030. This ensures resistance against physical damage from soil movement, rocks, and excavation. Grade 1030 aluminum, being softer, is more vulnerable in underground environments. The use of grade 1030 aluminum introduces risks such as increased electrical resistance due to its lower conductivity, leading to potential energy losses and overheating. Its reduced resistance to bending and pulling forces during installation and repairs also poses a threat. Ignoring these factors can lead to severe consequences, including electrical outages, equipment damage, fire hazards, and safety risks for personnel. Adhering to NEC guidelines is crucial, ensuring the use of grade 8000 aluminum wire for safe and reliable underground electrical systems. Firstly, it is essential to understand the specific requirements outlined in NEC section 310.14 D regarding aluminum conductors for direct burial. Secondly, assess the mechanical properties of different aluminum grades, focusing on tensile strength and yield strength, and their relevance to underground applications. Thirdly, carefully evaluate the risks associated with using grade 1030 aluminum for direct burial, including potential physical damage, increased resistance, and the possibility of failure under stress. To elaborate on physical damage, consider that the underground environment is dynamic, with soil movement, rocks, and potential excavation activities posing constant threats to buried cables. The superior strength of grade 8000 aluminum ensures that the cable can withstand these challenges without being compromised. Grade 1030 aluminum, on the other hand, is more susceptible to punctures, abrasions, and other forms of physical damage, potentially leading to electrical faults. In terms of increased resistance, the lower conductivity of grade 1030 aluminum can result in higher energy losses, leading to increased operating costs and potential overheating. This is particularly important for long underground feeders, where voltage drop can be a significant concern. The use of grade 8000 aluminum helps minimize these issues, ensuring efficient and reliable power delivery. Moreover, the potential for failure under stress is a critical consideration. Underground cables are subjected to various forces during installation and repairs, including bending and pulling. The superior strength of grade 8000 aluminum allows it to withstand these forces without being damaged. Grade 1030 aluminum is more likely to be deformed or damaged, potentially compromising the integrity of the electrical system. Therefore, it is crucial to prioritize safety and reliability by using grade 8000 aluminum for direct burial applications, as mandated by the NEC. The NEC provides detailed guidance on conductor types, installation methods, and safety requirements for underground electrical systems. Compliance with these standards is essential to protect people and property from electrical hazards. When designing and installing underground electrical feeders, it is important to consult with qualified electrical engineers and contractors who have experience in this area. They can provide valuable insights and ensure that the system is designed and installed correctly. In addition, it is important to conduct regular inspections and maintenance to identify and address any potential problems before they become serious. This includes checking for signs of cable damage, loose connections, and overheating. By following these best practices, you can ensure that your underground electrical feeders are safe, reliable, and compliant with electrical codes. Proper selection and installation of underground electrical feeders are crucial for the reliable and safe distribution of power in a variety of applications. The NEC provides comprehensive guidelines on the use of aluminum conductors for direct burial, emphasizing the importance of using grade 8000 aluminum to ensure the mechanical integrity and electrical performance of the system. The use of grade 1030 aluminum for direct burial is not recommended due to its lower mechanical strength and increased susceptibility to damage and failure. This can lead to a variety of problems, including electrical hazards, equipment damage, and code violations. Therefore, it is essential to comply with NEC requirements and use only grade 8000 aluminum wire for direct burial applications to ensure the safety and reliability of the electrical system. Remember to consult with qualified electrical professionals to ensure that your underground electrical feeders are designed and installed in accordance with all applicable codes and standards.